going to have some fun with helpers, operator overloading, and all kinds of helpers. Nullable types. In Delphi, with a lot of techniques. I chose this topic because over the last 10 years or so, a couple of really interesting features got introduced in the Delphi language, and this is a way to combine them all and show a lot of nice things about the language. And why? Well, because you can. No, kidding. Nullable types are one of the things that are absent in the Delphi language. So you cannot have an integer that has no value. And I created a set of records that allow you to do exactly that. And all the code is on the bo.codeplex.com code repository, and you can access it with Subversion or through a Team Foundation system. If there's enough time, I'll show a little bit about that on the end of the session. So, step by step, we go through a lot of technical details. First, nullable types. Who can imagine he could use nullable types somewhere in his language?
Yes.
Okay, yes.
For the times when you don't know the value. For example, typical good example of nullable type is the new, maybe, however it's called, XE3. It's a Boolean value with not initialized.
Yes.
True, false, not initialized, sorry, I have no idea.
It's for places in your application where you do not know upfront a value of a variable. And a perfect example is a user interface where the user needs to type in a value, so you cannot give it an initial value like 0. Places where you see this a lot are databases. Most modern databases, most databases for the last 30 years allow all the values to be empty. So fields in your database can be absent, and that's what a nullable type is about. And null is a state, it's not a value. Who remembers Bill Carwin? He used to be one of the Interbase guys, and he had this mantra on in the signature under every message. Null is a state, not a value. Null means there is no value, and that means that databases do specific stuff with it, and the records I'll show you mimic that behavior. There are currently many languages in the .NET arena that allow nullable values, and other languages that have similar behavior, and people have a hard time working on that. So Delphi native doesn't do it. The .NET version of Delphi does it. There is one data type that comes close, which is variant. Who has been using variant data types? Okay. All the field in the database layer of Delphi have a value property that can be variant. Who hates the variant data type? Okay, that's all of you guys that just raised your hand when using it. And the bad thing about variant is it does conversions behind your back, and you're not completely sure what kind of conversions it does in which order, especially when transforming numbers from strings to number and doing rounding with a decimal comma or a decimal dot or not. I try to avoid variant. And this was, in fact, one of the major reasons that I started developing these types, because I was so fed up with the behavior of variant and debugging code that I couldn't explain to myself that what end users were seeing on their computer and their configurations. There's a couple of things that we need to know about, and I'll address all of them during this presentation. I'll start with something very simple but important, the distinction between reference types and value types. Then we go for operator overloading, then to helpers. I'll do a small sidestep when time permits on the new helpers that were introduced in Delphi XE3. And then we are going to talk about properties and the object inspector, because it would be really, really cool to have nullable behavior in the object inspector at design time. And for that, you need a little bit knowledge about type information. One of the things that I wanted to do is make calculations involving nullable a lot easier than with variance. Because with variance, you don't see the underlying type that is there and how it would affect your calculations. And with these nullable records, you will. And my aim was to make them function like in SQL, and as a side effect, make it easier to transfer data from the database into nullable types and back. Okay. Who is using anything before Delphi 2007? Okay. If you do, most of the code will work from Delphi 2006 onwards. All of the code will work from Delphi 2007 onwards. So if you're below that, you're going to have a hard time using this code. With the introduction of Delphi 2009, you got generics. It is technically possible to make a generic nullable type. It is going to be a lot of work. And there's Alan Bauer showed one behavior of nullable for comparison to equal or not equal, and he needed to do a lot of dirty tricks to implement those, and making that work for all the possible operators is a lot of work. So I decided not to do and keep my current solution, and it still works very well in modern versions of Delphi. What's a value type in Delphi? Can you guys give me examples of value types in Delphi? Okay, let's ask the question the other way around. Can you give me examples of reference types in Delphi? Sorry, D?
An object.
An object, yes. Basically anything that points to something, which means pointers, records, methods, but not records. Strings are a bit in between. Basically anything that when you copy it retains the value is a value type, and anything then when you copy involves copying a reference is a reference type. And that makes things a bit complicated, so let's give a couple of more properties of them. Value types usually live on the stack, and reference types usually live on the heap. When you assign a value from a value type, the whole value is being copied into the destination. And for copying a reference type, only the reference is copied. So when you have two variables having a reference to the same memory area, they share the value. So when you change the value, both of them will change. That's the most important thing to remember. So most simple types and records are value types, and objects are always reference types. And then you have interfaces, which are a way of indirection. Interfaces do not have values themselves, they refer to values, so they are kind of reference type too. Pointers and strings are somewhere in the middle. The behavior is like they are value types, but their actual storage is on the heap. Yes. I'm generalizing. It's 99% of the time. Short strings, for instance, are value types, and you don't want their values to live on the stack because a string technically can be 2 gigabytes of characters, and copying that on the stack will blow your stack, and you get instantly a stack overflow. So you don't want that. So the actual storage of strings is on the heap. So the storage is like they have reference types. The compiler all shields that away for you. So from a usage perspective, they behave like value types. I want to show a quick example of having a value integer and a reference integer. So you have an integer and a pointer to an integer. So this is A and this is B, and show you what happens when you assign stuff to it. So when you assign 4 to it and it's a value type, well, when you assign 5 to it, when you assign B to A, and when you change the value of A. In the end, you must remember, this is important because some of the code will be based on records and some of the code will be based on classes. Classes are reference types and records are value types. So for most of the behavior where they are record types, you will see the leftmost behavior, and occasionally you will see the rightmost behavior. So to fully understand the code, this is a little bit of knowledge that you need. So reference types have pointers, and one of the things with reference types is that as they're local variables, they might start as uninitialized. So the pointer isn't nil, but might be a random value pointing somewhere in memory. And this is what happens. 4 and 5, 4 and 5, and this is the most important distinction. You assign B to A, and both now point to 5. And then when you assign 6 to B, on the right side, both will show 6 as their value. Okay. I wrote a small console application that demonstrates this behavior. If you want to try that, the code will be electronically available. Equality and inequality can become tricky when you have reference types, because you need to determine if they should work on the pointer or on the underlying value. So are A and B equal to each other? That depends on the equality operator and the inequality operator. From a pointer perspective, they are not. Sorry, they are. But if A had been 5 and B had been value 5, then from a pointer perspective, they would be different. And from a value perspective, they would be the same. This, for instance, matters with strings pointing to different memory areas that have the same contents. Strings solve that for you. When you do your own typing, you need to be aware of the distinction. Okay. So all of this led me to my choice of using records as a base for nullable types. And that was before I started to look into operator overloading. So this is what I started with. A record with 2 fields, the actual value, and a boolean indicating if it would be null. The drawback of having a field is that if I set the value, the isNull field will not automatically become false, which I want to. So I need to introduce properties and get and set methods. And the cool thing is, operators are nothing but methods formulated in a certain syntactical way. So there's a mapping between method names and the operators that Delphi implements. The cool thing is, I had been working on Nullable Type before operator overloading got introduced in the native Delphi world. So I had methods like add and multiply and subtract, etc. And then I found out that I think it was somewhere in Delphi 2005 or 2006, they moved operator overloading from the Delphi.NET compiler into the native Delphi compiler. And in the Delphi.NET compiler, it was implemented for classes, but in the native Delphi compiler, it was implemented for records. The reason is that .NET has a garbage collector. So memory that you don't use will be given back to the system after a while automatically by the garbage collector. The native version of Delphi doesn't have a garbage collector. So if you leave an unused object somewhere on the heap, it will not be automatically freed. That's cool because I already chose records as the base for nullable types, and now I suddenly had operator overloading. So all the syntax starts with the word class operator. So for instance, multiplication, you have the multiplication operator. It has the name multiply, and the multiplication operator requires two operands, A and B. And there are two versions of the minus operator. One of them is subtraction from two values, and the other is to change the sign of a value from positive to negative, and from negative to positive. One of them has two operands, and the other one has one operand. So this is the syntax for this operator. Class operator multiply, you get two operands. I called them A and B. If you have more screen space, like not on this presentation, but in real code, I usually call them left and right, because it's the left side and the right side of the operator. And what you see is that you get record as parameter type and record as result. The compiler allows you to have different types for the parameters and different types for the result within some boundaries. That can make stuff a lot more complex, but also powerful, because you can have an operator plus for an integer and a floating point value that returns a floating point value. There's a whole series of dull tables that back then, when I wrote this, was not online in the documentation. And while I wrote it, it started to appear in the documentation, but the documentation wasn't always right. And since a couple of years, the documentation is right. But these tables give a shorter overview. There's one operator that's not available. It's the bitwise not operator. Luckily, there's a logical not operator that you can use instead. So this is a whole series of operators and their actual names that you use as class operator name. And what you see is that most of them have two arguments, a couple of them don't, and things like decrement actually are operators. So they look like function names, but they are actually operators. What you have to watch for is when you are going to work with equal and not equal, and greater than and less than, and keep in mind that the opposite of greater than is not less than. I'm sure that you made the same mistake as I've done a million times before. These two are not their opposites. This is the opposite of this, and this is the opposite of this. It's easy to get wrong. Okay, the documentation now is correct, because I think a couple of weeks ago this changed. Until recently, they told that it would only work in the Win32 world. It works in the Win64 world as well, and it also works in on the Mac world. And as soon as they reintroduce mobile support, it will work with mobile support as well. The most important restriction on data types is that at least one of the operands must match the actual data type. So the data type here is nullable double, and for instance this one, and at least one of them needs to be of type nullable double, and there's no restriction on the result type. This is not in the documentation, but it is something that the compiler will enforce. The result can be any type, so use your imagination and make it something useful. This is very important for conversion operators like the implicit and the explicit conversion operators. Be very careful with implicit operators. I'll follow up on that a little bit later. Most operators you want to overload pairwise. So you want to overload add and subtract at the same time. The compiler does not enforce that, but it's wise to do that way. Same for greater than and less than equal, equals and not equals, and stuff like that. Use common sense there. Another important thing, though you can deviate from that, is that you should not use a star operator, a multiply operator, to do something completely different. That's not completely true, because in exceptional cases you can. I think it was an Australian guy that uses operator overloading to do XPath, which is XML querying, in a brilliantly simple manner. And he uses slash and multiply to do very different things, because for searching you don't have multiplication for searching and you don't have division for searching. So he applies it as contains and stuff like that. So for those exceptional cases you can have an operator that has a totally different meaning than what you normally see in code. There's two ways of conversion. You can have an explicit conversion operator and an implicit conversion operator. Be aware that when you do implicit conversions and the compiler sees a path from A to B using an implicit way, it will use that way instead of the explicit one, which can cause conversions just like variance does, which you try to avoid. What plays in the background is that the compiler automatically does a couple of implicit conversions for you. For instance, from byte to integer, or basically from a small type to an encompassing bigger type. And it does implicit conversions from variance to anything. So in practice, most of my conversion operators are explicit. And this is the foundation for a nullable integer. So what you see here, it has, well, this one is for the example, so it's in practice it isn't there. It starts with if it's filled or if and the value that it has, which means that it doesn't have a field is null. It has a property is null that uses a method get is null that gets the negation of is filled. And the reason is that I find it much easier to read code that is formulated in a positive way than in a negative way. The negative way would be not null. The positive way would be is filled. That's a personal thing. I know programmers that cope very well with double negatives. I know politicians that work very well with quadruple negatives. I try to keep it as simple as possible for myself. So this is all strict private. The reason is that you cannot overwrite records. So classes, you can have descending classes that overwrite existing behaviors, not so with records. I regret that because that would have made my code so much easier to write. And then a class function compare that I use with comparison operators just returns 0 when it's equal, smaller than 0 when A is smaller than B, and larger than 0 when B is larger than A. And it allows me to have the comparison logic into one function, and then the operators are just small wrappers around this function call. And I have a parse function because it's much easier than to have parse on a lot of places that have different Delphi functions that you need to call. And all of them have a toString. This was before Delphi added toString on the T-object level. You got a lot more operators and then a couple of properties here. A value, I think I've thrown an exception when you ask value and there's actually null, so it doesn't have a value. So this is the foundation for all my nullable types, and the rest is syntactical additions. So a couple of examples of methods. And how I design this stuff. For addition, you need to ask yourself, what would null plus a value mean? When you use databases, almost all the databases, when you add null to something, will get you null. a couple of people laughing, because that highly affects how you formulate your SQL queries to a database. And if you do it the wrong way, you get a null result when you don't expect one. The exception for databases is when you have a sum operator over a set of values. Then it will add the non-null values together and give you that result, which is very handy when you have currency values in your database. So with currency values, I will assign a value when either one of A and B have a value. So this one mimics the sum behavior in SQL. And otherwise, I'll clear the result. And for all other data types, I only give a result when both A and B are filled. So both of them are not null. This mimics the standard database behavior of using nulls in databases. So this is the exception. This is the normal case. And this is a choice you need to make. What's more logical for your Delphi applications? Be similar to what databases do, or be similar to what standard Delphi data types do. So you can change my code and go through all those methods. And in retrospect, I haven't done that, but years ago when I started this, I should have made some option on the record type level if I by default would be database similar to database behavior or similar to normal Delphi behavior. That's things that time teach you. You might have done stuff differently. Okay, this is the standard compare thing. I won't go into detail. It takes care of both comparing the value and the is null or the is filled to get the right result. Which means, okay, less than just calls compare. Less than equal just calls compare. All the comparison operators are very simple calls, and therefore very easy to spot if they're right or if they're wrong. There is a couple of the methods for assigning a value, which makes sure that is filled becomes false. Setting is filled when you set is null. Set is filled, which calls clear. Null, which calls clear. Get is null, etc. This is very similar code in all these classes, and one of the things that I tried but I stopped is use a kind of include files with a parser that was too convoluted. And this is the original reason that I wanted to have nullable. This is a calculation for calculating the diopter. The diopter is the strength, the optical strength of glasses or lenses, etc. And you have relative diopter for two lenses that are a certain distance apart. And this code was for a company that makes glasses for wearing. And depending on your nose, your glasses will be closer to your eyes or more away from your eyes. And that's what HA stands for. It's a Dutch abbreviation for the foremost part of your eyes. I don't know the English word for it, but it's the clear thing that your eyes see through. It's not your lens because that's behind it, and it's the distance between that and your glasses in millimeters. This uses nullable types. When phrasing this with a series of if statements and is null would get me, for all my calculations, a method that was like 50 lines long. And those methods were very, very error prone. And this application does a lot of calculations with all kinds of stuff with glasses. You can have cylinders and prisms and all kinds of strange stuff that you want to calculate on. And in the user interface, a lot of places allow you to enter nothing as a value because then the patient doesn't need that. And the calculations still need to take that into account. I wanted simple code like this to be there. And this works with the records that I've introduced. So this was the goal. Took me about half a year to reach the goal and make it bug-free. Now about helpers. Helpers were actually introduced for the Delphi.NET compiler. Then the Embarcadero, no, back then it was the Borland engineer said, well, we've introduced helpers, but don't make them your own. They're for internal use only and not for the public world. It allows us to map Delphi-like functionality onto the .NET framework. And then when they got introduced in native Delphi, they still said, well, don't try this at home. I tried and it works. What you can do with a helper is add functionality to an existing class. And since then, also to an existing record. And since Delphi XE3, also to an existing simple data type. So you can extend the string data type. There's actually, which means that now you can ask a string.indexOf. So you just start a quote, then a couple of characters, then another quote, then point, and then index off. This is cool. The reason they introduced this in Delphi XE3 is that they're working on a new generation compiler for the mobile world, and the new generation of strings will be 0 based. So the first character starts at position 0. And this one will make sure you can access it both on a 1 based way and on a 0 based way. The underlying reason is that the backend of the compiler will be based on LLVM. And LLVM is an open source project that has a lot of targets. So for instance, there is a target for ARM on iOS, there is a target for ARM on Windows Mobile, there is a target for ARM on Linux, there is a target for Intel on Linux. So when Embarcadero creates the compiler frontend for the Delphi language, they can use the LLVM backend for virtually any platform they wish, which is very powerful. The thing is, LLVM is based on C, and in C all indexes are zero-based, including strings and character arrays. And that's why most likely the new string type will be zero-based, and they started introducing this one so that third-party authors can make all their string stuff based on this one, and make sure this will work in the future without a lot of changes. So they can prepare now instead of prepare somewhere next year, when it's, well, earlier this year they said the mobile stuff will be somewhere next year. And I think they will make that. Okay. Back to here. You can add methods and properties. You cannot add data to an existing type, because then you would enlarge the storage, which you cannot do from the outside. This was needed in Delphi 2007 to keep binary compatibility with Delphi 2006 packages and component libraries, etc. I created one like this, a format settings helper, because T-format settings got introduced somewhere, I think in Delphi 2005 or 2006, and it encapsulates all the format settings, like the option between decimal, comma, decimal dot, the number of zeros behind the comma for money, the money character, if negative number should be within parentheses, etc., etc. And you can use this for formatting numbers and parsing numbers. One of the things that it didn't do was get the default one for you. The other thing, what it didn't do is convert from a day name to the internal day name index. And there is two different ways you can have weekday indexes. One of them is inside Delphi, and the other one is used inside T-format settings, and I wanted to have a conversion between them. And the other thing that you couldn't ask is the current Windows locale ID, which is the current language setting for the user that's running your application. So I wrote a simple helper for that. So whenever I have a T-format settings instance, I can call these methods. And this is the wrapper. So this is the default locale ID. Then if you set it, it stores it and then sets the thread locale. If it was -1, then it asks it and then it caches it, because I wasn't sure how expensive this call was in Windows, and this does the mapping for you. It's a very simple helper, but very useful. You can set the locale ID for a couple of things and then ask the weekdays for it. So Monday, maandag in Dutch. This is Friesisch. It's not French, it's Friesisch. It's a separate language in the Netherlands that's spoken in one province. And you can change that. The thing with helpers is that you can use them as long as the helper is visible in the context. And that's why the string helper is in the sysutils unit, because the sysutils unit is in almost every users list. So if the original data type is in the users list, but the string helper is not, you cannot use the helpers. Another thing is that you cannot, for record helpers, you cannot override, like you can, let's rewind. For class helpers, you can overwrite one class helper by another because you can overwrite one class from another. Since you cannot overwrite a record from another record, you cannot overwrite a record helper from another record helper. This is a compiler limitation. It would be so much more useful if you could overwrite record helpers, and there is in fact a QC entry somewhere, and well, if you like this, please vote for that QC entry. It was not mine, my entry, someone else entered it. And where I use it for is for conversion between database fields to nullable types. So I have helpers for all the kind of field types that introduce a property as nullable double for the double field, as nullable integer for the integer field, etc. And now it's very easy to ask your database for a nullable value. It's a very simple statement. The helpers are also very simple, but it saves you lots of places with code similar to that. And this allows very simple code to get from an ID in the database. I'll create a SQL query, and the IDs in the database are string-based. The reason is that the underlying database has a 64-bit ID, a 32-bit ID, which wasn't big enough to store all the possible IDs. So I asked the string for an as-nullable string, for an as-nullable double, and an as-nullable integer. So I get very simple code for mapping from the database to records that contain nullable values. And that was my aim, to make my code much, much easier to read and maintain. And the underlying reason was the code was so complicated, it had lots of errors in it, and the quality wasn't high enough to release the application to the end user. And by introducing this and investing about half a year of work, it's not half a man year, it's half a year that it took from initial stage to final stage, made the quality of the application much, much better. And this is similar to my unit testing talk. When developing applications, you need to think about ways to improve the quality of your application. And sometimes you need to do very complicated stuff, or what you think initially is very complicated stuff, to make your code way more easier to use. In this case, it was making use of nullable types based on properties, helpers, and operator overloading. But we have all made the change from procedural programming to object-oriented programming. Lots of people have made the change from class-based programming to interface-based programming. Sometimes you need to make a jump in order to reach a new goal and make your applications easier to maintain. Okay, let's go to properties. No, let's do a couple of demos first. Okay, let's get back to Delphi. So the code is in a big project group which contains two packages. The general runtime package and a package for nullable controls, and a couple of demo applications. This is the operator overloading console project. It's simple. It shows you for a my record a couple of overloaded operators. Underlying is a whole logging framework. And not even all the operators are implemented. It's just to show you that you can have less than between a record and a class, that you can round a record into a class, and that the resulting data types do not need to be the actual parameter types. So you can do very flexible things with it. I didn't do for nullable types because it was not needed, but the Australian guy did it for doing XPath stuff, and he needed it, and it was very, very useful. Okay, then there is the nullable types on the console, showing things about nullable integer. So what it does, it clears left and right, so they're null. Then it shows the sum of left and right, then assigns 4 to left, so there is an implicit operator for converting an integer to a nullable integer. That makes sense. There's no implicit one for integers to nullable double, because the compiler does that for you, so I'm using common sense here. So this one shows the sum between for those values. For the presentation, I collapsed the nested if statements in with an AND. All the code started as this with include files, which I later removed because it's easier to follow and easier to add comments for the different branches of the if statements. And then there's value that reads the value, and then there is toString, which when there is a value calls int to str, and where there is no value returns null as string value, and null as string value is declared in the variant unit, which is the standard empty string. I use null as string value a lot because this way you can override what it will show for an empty string. So if you want to have null in brackets, it will use this. Here are a couple of controls that have nullable values. Oh, I should have given the buttons a proper caption. Okay. What the set null button does, it assigns the nullable integer .null to the nullable integer static text, and the other one sets a random value to the text. So set null makes this one become null, and this gives it a random value. So for that, I wanted to have a nullable static text, and for a nullable static text, I wanted to be able in the object inspector to have a value. So when I set is null to true, it clears itself, and when I set it to false, it becomes 0. I use 0 as the default value to return to when you set it to null. The cool thing is, when you give this a value, then is null gets cleared, becomes false again. In order to have properties like these, they cannot be records, because records don't generate type information, and type information is needed for the object inspector to show properties. So I created a tnullable integer wrapper that is a class, not a record. Because for a class, you can generate runtime type information and have something like that, a published property. This took quite a while for me to realize the implications, because I started with records and tried to get them into the object inspector, and then the object inspector wouldn't show me. And I thought, what the heck? It can show integers, it can show strings, it can show t-persistent. Why can't it show records? And then I found out about the runtime type information. There's no runtime type information. There's no classic runtime type information for records. In the meantime, I think it's since Delphi 2010, maybe 2009, they introduced new style runtime type information. It might be possible. But then this code started in 2006, survived a couple of Delphi migrations, is used in old and new Delphi versions. I didn't want to change all this code and make it use records in one version of Delphi and classes in the other version of Delphi. So I kept it that as an intermediate class with wrappers.
2010.
Okay, new style runtime type information was added in Delphi 2010. There have been so many Delphi versions that sometimes I forget which feature got introduced. That's why I have slides for most of those things. So the value here is a published property, and there is a value editor. And what you see here, the value is of type T nullable integer, and the value editor is of T nullable integer wrapper. And the wrapper is quite complicated. This started as a very small class, but then I realized that there is a dynamic binding not only from the wrapper to the component, but also the other way around. You will not see that for a static text, but you will see it for a nullable integer text, where the user can edit the value, and when it presses the delete key, you want to assign null, and when it enters a number, you want to assign a value. And that's why it has get is null, get value, set is null, set value, but also an on change. And this is for notification between this and the user interface and the other way around. So it's much more complicated than you would think at first sight. I won't go into very much detail here because the presentation is aimed at operator overloading and helpers and stuff like that. But I want to show you that underlying, sometimes you need much more code than you think you'd need at first sight. The code is all there, so download it and be my guest, comment on it, and if you find it useful, tell me where you use it, because I'm always anxious to see what kind of code people use in certain circumstances. So there needed to be a wrapper, and the wrapper needed to be descending from T persistent. This is one thing that I do show. If you descend from T persistence, then a property that has sub-properties will automatically stream itself to the streaming system, which means that when you're here, you will actually see the values in the form. This is how it's streamed to in the DFM file, and that's why you need T persistent for that. Okay. Type information. I won't go into much detail on this. I'll open for questions and answers, because the rest is just syntactical sugar. There's a couple of things that you need to watch for. That's the last thing, and then we go to the questions and answers. Who is using Delphi 2006? Okay, great. Then this slide is moot. There was a bug in Delphi 2006 that would make this code very hard to use, and that got solved in Delphi 2007. So it's time for questions and answers and discussion. Who of you guys did do some operator overloading themselves? Okay, where did you use it for?
I have created a Unicode string which only can hold 255 characters, because I can't really remember why, but I needed it at this point of time.
Okay,
like a short string, but for Unicode.
Okay, you wanted to have a short string, but not with ANSI characters, but with Unicode characters. Okay, cool. Yeah, cool. That's a very nice example. Other people that did the same with operator overloading? Okay, did anybody use helpers? Yes?
Yes, use a class helper. I use a class helper for extended DevExpress grid without extend the grid.
Yeah, yeah. That's the standard reason for creating helpers. You have a class library that's not yours, so you cannot change it. And if you get a new version and you did change it, then you need to reapply all the changes to it, which is a pain. So then you write a helper for it, a record helper or a class library to extend the functionality. And then usually that keeps working with a new version of the class library. This is exactly the reason that it got introduced in Delphi 2007. They wanted to keep most of the VCL and the RTL the same, especially in the interfaces to the outside world. But Delphi 2007 was introduced for Windows Vista support. So you needed to have arrow glass and user account control and stuff like that. So the underlying functionality had to change, but the interface could not change, and they introduced Delphi helpers there. Well, in fact, they introduced it in Delphi 2006 to make sure it was stable in the compiler, because back then it wasn't sure when Vista would appear. It's like any product. When will it appear? Well, it might be this year, it might be next year, it might take 2 years. So they made sure the compiler would support it, was stable enough, so they could make the transition for you before making the big Unicode move. Because back then they knew that this compiler would probably, most likely, be the last compiler doing ANSI characters and ANSI strings instead of Unicode characters and Unicode strings. Contact me if you have any more questions, and thanks for attending this session.